Welcome to AI Podcast. Today we're unpacking a new EMNLP findings paper called OAgents. And the short version is this: solid modular choices beat flashy orchestration.
That's a strong claim. When you say modular choices, what are we talking about exactly?
4 building blocks: how the agent plans, how it uses tools like web search and file readers, how it remembers things, and what you do at test time, like sampling a few answers and picking the best. The authors show that tightening those basics moves the needle more than inventing yet another complicated multi-agent storyline.
Right. So instead of building a Hollywood cast of agents, it's about getting one team to do the fundamentals well.
Exactly. And they back it up on the Gaia benchmark. With their setup, results land around the mid-60s for single-try accuracy and bump into the mid-70s when you allow a few attempts and take the best one.
That's respectable. Who's behind this work?
Lead authors include Heju and Tianrui Qin, working with Oppo Research Institute folks and collaborators from places like Nanjing University and Yale.
Got it. Let's set the stage. What problem are they trying to fix in agent research?
Reproducibility and apples-to-apples comparison. Agent papers often differ in tiny undocumented details, prompts, tool chains when they let the model try again, things like that. Those choices can swing results more than the headline method. This paper tries to standardize the choices and then ask which components really matter.
Okay, so they clean up the playing field before they keep score.
Exactly. And they introduce a helpful way to think about agents on 2 axes. First, factual acquisition, meaning how well the agent brings in the right information from the outside world. Second, logical reasoning fidelity, meaning how reliably it thinks through multi-step tasks.
I like that split. Factual acquisition is like grocery shopping, and reasoning fidelity is the cooking. If you buy the wrong ingredients, no recipe saves you.
Perfect analogy. On the shopping side, they use multi-source search rather than relying on a single engine. And they add a structured reader to pull clean text out of messy pages and PDFs. They also make the agent comfortable with images, audio, and spreadsheets, so it can handle those formats instead of pretending everything is plain text.
And on the cooking side?
3 things: planning that can revise itself as it goes, a memory stack that separates short-term notes from long-term knowledge, and test time scaling, basically asking the model a few different ways and picking the best result instead of trusting the first thought.
Let's linger on planning for a second. What does dynamic plan revision look like in practice?
Think of a to-do list that rewrites itself. The agent proposes a plan, checks progress, adjusts the steps when it hits a snag, and uses little plan tips learned from past mistakes. Those tips are like sticky notes from yesterday's debugging session, so the agent avoids repeating the same errors.
Nice. And memory?
Short-term summaries keep the current conversation light, vector search helps retrieve relevant past steps, and long-term memory stores patterns that keep paying off. There's a caution, though. If you over-summarize, you can throw away the one detail you'll need later.
Classic meeting notes problem. You compress, then you forget the one number that mattered. What about test time scaling?
Easiest to picture as burst mode. You generate a handful of candidate answers and choose the best via simple checks. It's like taking 3 photos and keeping the sharpest one. They also tried reflection, where the model critiques and revises itself. But that turned out to be touchy on the hardest tasks. Sometimes helpful, sometimes it dug a deeper hole.
Okay, let's talk evaluation. You mentioned Gaia, but what did they do differently to keep it fair?
They standardized 2 things people often mix up. First, they report both single-try accuracy and the best of accuracy when you allow a few shots. That matters because some leaderboards quietly report one or the other. Second, they set rules for when it's okay to re-answer, like if the model literally returns nothing, so you're not gaming the metric.
So the scoreboard's finally readable. Now the fun part, what actually moved the numbers?
The big gains came from better intake and pragmatic planning. Multi-source search plus a structured reader outperformed naive browsing. Handling images and files properly unlocked tasks that used to be dead ends. On the reasoning side, those plan tips, simple heuristics from error logs, were surprisingly impactful, and best of sampling gave a clean, consistent boost without much complexity.
Any surprises?
2. First, reflection wasn't a slam dunk. On the trickiest long-horizon problems, letting the model rewrite itself could amplify early mistakes. Second, memory is not more is better. Summaries help, but if they compress away nuance, you lose ground on hard questions.
That's honest and helpful. What about the model backbones? Is this only for one vendor's LLM?
They tested several. The framework lifted multiple models, both open and closed, so the lesson travels. Good tools and disciplined workflows are portable across backbones.
Now for the skeptical hat. Where should listeners keep their guard up?
A few places. Some multimodal ablations were on small subsets, so big percentage swings need more data behind them. The system relies on external APIs for search and reading, which can rate limit or change behavior, so reproducing results in the wild can be finicky. And while they focus on Gaia for depth, broader interactive benchmarks would give stronger evidence that the approach generalizes.
That's fair. Did they release anything for others to try?
Yes, code is available, and it's permissive, so teams can inspect the prompts, plug in their own keys, and run the ablations.
Love that. Let's translate the paper into Monday morning advice. If I'm building an agent, what should I do first?
Start with intake. Add multi-source search and a reliable page or PDF reader so you ingest clean text. Next, add dynamic planning with a small library of plan tips distilled from your own failure logs. For memory, keep summaries modest and verifiable, and store enough context to revisit tough steps. Finally, use best of sampling for important queries so you're not hostage to a single roll of the dice. And when you report results, include both single try and best of metrics.
That sounds doable. No moonshot, just discipline. Any analogies you like here?
Sure. Think of it as building a newsroom. Your reporters gather facts from multiple sources, your copy desk cleans and formats the material, your editor lays out the plan and revises on the fly, and before going to print, you look at a couple headline options and choose the one that reads best. Reliable newspapers don't rely on magic. They rely on process.
That lands. One more thing I'm curious about. You said reflection can backfire. Is there a safer alternative?
A stronger verifier. Instead of asking the model to rewrite itself freely, you give it a clear checklist or an external check, like cross-referencing entities or sanity checking dates, then pick the candidate that passes the most checks. It's less romantic than self-reflection, but it tends to be sturdier under pressure.
Right. Guardrails, not vibes. And the author's angle on fairness in reporting, why should listeners care?
Because pass at one versus best of makes a practical difference. If your product only takes one shot, single try accuracy is the truth users feel. If you run a search and can afford a couple tries behind the scenes, then best of represents what you ship. Being explicit about both keeps the community honest and helps teams make cost-quality trade-offs on purpose.
Speaking of cost, did they say anything about efficiency?
Not as a primary goal, but the pattern suggests low-hanging fruit. Better readers reduce wasted tokens, and best of, with a small n, tends to give a very favorable accuracy jump for the price.
Before we wrap, give me a crisp takeaway.
Sure, strong agents are built, not conjured. Get better at finding and cleaning information, plan with feedback, keep memory helpful but humble, and pick the best answer from a few sensible tries. Do those, and you'll often beat fancier architectures.
Nicely said. What should researchers explore next?
Shared, public evaluation protocols with seeds and per-task logs, more robust verifiers instead of free-form reflection, broader interactive test beds beyond Gaia, and options that reduce dependency on third-party APIs so results are easier to reproduce.
And credit where it's due. Thanks to Heiju, Tianrui Qin, and the broader team for a careful, transparent study.
Absolutely, that's OAgents on the AI podcast. If you try these ideas in your own stack, let us know how it goes.
Thanks for listening. See you next time.